If you are the person in your office, tasked with buying the winter gear this year, you might think you can just hand your company logo to a custom apparel shop, pick out a nice fleece-lined hat, and just be done with it.
Oh, I mean, that is the assumption everybody makes. It's just a hat, right?
Right. But if you've ever actually done this and received a batch of branded beanies where the logo looks like this squished, puckered mess after a single wash, you are definitely not alone.
Yeah. Transitioning your brand's logo from a standard cotton t-shirt to a stretchy winter hat, it literally completely breaks the laws of physics that standard embroidery machines rely on.
Which is our exact mission for today's deep dive. We are laying out a clear step-by-step walkthrough on how to embroider a beanie with a business logo. We really want to give decision makers out there a straight, no-nonsense answer on how this process actually works under the hood.
Because there are so many mechanical pitfalls that just completely ruin the final product.
Exactly, and we're going to cover how to logically decide whether to tackle this in-house or just order custom. We're pulling all of this from a really comprehensive guide written by Connor Smart, who is an apparel expert whose studio has produced custom gear for, over 1,000 U.S. businesses.
His perspective is incredibly useful. He catalogs the granular, mechanical mistakes people make every single week. He documents not just what works, but the underlying physics of why certain methods absolutely fail at the machine level.
Quick honesty, this show is made by the team at Arklavo, so this is our genuine take, and you can weigh it for what it is. But the reality is, we all want our team to look sharp.
Absolutely. You don't want your staff walking around in warped gear.
No, definitely not. So to understand why putting a logo on a beanie is notoriously difficult compared to a t-shirt, we have to start by zooming way, way in on the microscopic structure of the fabric itself. So let's unpack this. Why is a standard beanie so incredibly hostile to an embroidery needle?
Well, it really comes down to how the material is manufactured. Most basic machine embroidery tutorials just assume you were working on woven fabric. So materials like cotton twill, canvas, or a standard button-down dress shirt.
Woven fabric is structurally rigid, right?
Exactly. The manufacturing process literally takes threads and crosses them over and under each other at crisp right angles, which creates this tight grid. And because of that interlocking grid, the fabric holds its position perfectly under the tension of an embroidery needle.
It's stable, like if you press down on it, it pushes back. It's like trying to draw a picture on a solid wooden desk. The desk isn't going to move while your pen is moving.
That's a great way to think about it. But a beanie is not woven. It is knit fabric. Instead of a grid of intersecting threads, a knit is essentially one continuous piece of yarn that is just looped back on itself over and over again.
It's just a series of interlocking loops.
Right. So when you push a high-speed needle through knit fabric, those loops naturally want to move. The fabric stretches, it twists, it just shifts totally out of the way. It is designed to have a tremendous amount of give.
Which means my wooden desk analogy completely falls apart here.
Yeah, it totally falls apart.
Trying to embroider on knit fabric is much more like trying to draw a perfect circle on a trampoline while someone else is actively jumping on it.
That is exactly what it's like. And when that trampoline is bouncing around under the needle, you trigger two major physical failures that you almost never see on flat woven fabric.
Okay, what's the first one?
The first is logo drift. An embroidery machine moves at incredible speed. If the beanie is not held completely flawlessly flat and stable while the machine is running, the fabric will literally shift position mid-stitch.
Oh, wow. So you end up with a logo that looks smeared across the hat.
Exactly. Because the canvas was physically moving while the needle was trying to draw. The machine thinks it's hitting the same coordinate, but the fabric has physically traveled like a quarter of an inch to the left.
That sounds like a nightmare. And the second major failure?
It's puckering. Embroidery inherently involves pulling thread tight. If you pack too many dense stitches into one area, the tension of that thread just pulls those stretchy knit loops together. It creates this rippled, pinched surface all around the edges of the design.
I've totally seen that. It looks okay right off the machine sometimes, right?
Yeah, it looks fine at first, but it gets dramatically worse after the very first wash. The knit tries to relax back into its natural unpinched shape, but the tight stitches just refuse to let it.
Okay, well, if the fabric is this volatile and bouncy, the logical instinct is to just pull it as tight as possible, right? Just stretch it out like a drum so it can't bounce around.
And that instinct right there is the single biggest mistake buyers and DIYers make. They try to force stability by hooping the beanie as tightly as humanly possible, stretching it across the embroidery hoop to flatten it out.
But that ruins it.
Think about the physics of those loops we just talked about. When you stretch a knit, you warp the loops outward. The machine embroiders a perfectly round circular logo onto that stretched fabric.
Oh, I see where this is going.
Yeah. Then you release the hoop, the fabric instantly snaps back to its normal unstretched size, and your perfectly round logo instantly warps into a squished, compressed oval.
Ouch.
Tension is the absolute enemy of knit fabric. You have to preserve the structural integrity and the natural resting state of the beanie at all times.
So we're essentially dealing with a giant paradox here. You can't stretch the fabric because it will warp the logo, but you can't leave it loose because the machine will smear the logo.
Yep, that's the challenge.
So to stop the chaos while the machine runs, you have to build a temporary foundation, which brings us to the crucial setup steps of digitizing and stabilization. And I want to pause on digitizing because I honestly always assumed you could just upload a high-resolution JPEG to an embroidery machine and hit print. Wait, I can't just hit print on my logo file. Why does a human need to map out a zigzag underlay just to stitch a logo?
I get that question all the time. People are just so used to the logic of inkjet printers, where ink simply sprays onto the surface. But digitizing is the highly technical process of converting your image file into a complex map of X and Y coordinates.
It's telling a mechanical arm exactly how to move.
Precisely. It plots every single needle pass, the stitch type, the direction, the color sequence. And because of the trampoline effect we just talked about, a human digitizer has to make very specific physical compensations for knit fabrics.
What kind of compensations are we talking about?
First, they have to reduce the overall stitch density by about 15 to 20% compared to what they would use on a standard woven shirt.
Because the knit has so much natural give.
Right. Dense fill stitching will just pull those loops together and cause that terrible puckering effect we mentioned. But the most critical adjustment a human digitizer makes is plotting the zigzag underlay.
I saw that in the source material. Why is a zigzag stitch hiding underneath the logo so important?
Well, think of the zigzag underlay as a physical scaffold. Before the machine starts doing any of the pretty top decorative stitches that make up your actual visible logo, it runs a wide, loose zigzag stitch underneath the entire fill area.
Oh, so it's physically tying the loose knit loops together?
Exactly. It locks them in place. It creates a stable structural floor. Without that floor, when the dense final stitches land, the whole design would just collapse inward into the stretchy yarn.
You are essentially building a rigid temporary floor on top of the trampoline before you start building the actual house.
That's a perfect way to visualize it. And the digitizer is also predicting the physics of the yarn itself. They have to adjust the design to account for something called push compensation.
Push compensation.
Yeah, as a needle repeatedly punches thread into the fabric, the physical bulk of the yarn naturally gets displaced and pushes outward. So a skilled digitizer will intentionally set the borders of the logo to be about 0.4 or 0.5 millimeters smaller.
Ah, they offset the spread knowing the fabric will push the design out to the correct final size anyway.
Pure structural engineering. You're predicting exactly how the material will fail and pre-correcting it in the digital file.
That is wild. But building this foundation isn't just a digital file, it's also highly physical. The source mentions a very specific sandwich of stabilizers you have to build around the beanie. What does that physical setup look like?
You basically need to control both the top and the bottom of the fabric. On the top, which is the visible face of the beanie, you need a layer of water-soluble topping film. It looks almost exactly like clear plastic wrap.
Why do you need plastic wrap on the top?
Without it, your stitches will sink deep into the Grand Canyon between those thick yarn loops and just completely disappear. The film holds the stitches crisp and high on the surface, and then it simply dissolves away later when you wash it in water.
Okay, that makes sense. And on the bottom.
Inside the beanie, against the wearer's forehead, you need a backing. You generally use a cutaway or tear-away non-woven stabilizer. The key word there is non-woven.
Because it doesn't stretch.
Exactly. Because the fibers in the stabilizer are bonded chemically rather than woven, it has basically zero stretch in any direction. Cutaway is generally superior for stretchy knits because it remains permanently attached inside the hat, providing long-term support for the logo so it doesn't warp after multiple washes.
But how do you physically get all of that into the machine without stretching the beanie? We just established that pulling it tight in the hoop completely ruins the hat.
Right, so you use something called the floating method. Instead of clamping the beanie itself inside the tight plastic rings of the embroidery hoop, you only hoop the stiff backing material.
So you stretch that non-woven backing so it's tight like a drum.
Yes, and then you spray it lightly with a temporary fabric adhesive. Finally, You just lay the beanie completely flat on top of that sticky backing, gently smoothing it out without applying any stretching force at all.
So the rigid backing takes 100% of the tension from the hoop, while the beanie is just resting on top, floating on the adhesive. That completely solves the warping paradox.
It's a lifesaver. It really is.
So, assuming we have this perfect digital scaffold and our beanie is floating flawlessly in the hoop, you can still completely ruin the hat if you attack it with the wrong physical tools. Let's talk about the hardware, the thread, the needles, and hitting the exact right placement.
Let's do it. The standard choice for the industry is 40-weight polyester thread for the main fill areas. Thread weight is a bit counterintuitive. It's a length-to-weight ratio, so a higher number actually means a thinner thread.
Oh, interesting.
Yeah, so a 40-weight thread is thick enough to cover the chunky knit background, almost like coloring with a heavy Sharpie. But for really fine details or tiny text, you switch to a thinner 60-weight polyester, which acts much more like a fine liner pen.
And the source specifically notes polyester. Why not cotton? Or even those really flashy metallic threads if a brand wants like a shiny gold logo.
Polyester is chosen primarily for its chemical durability. It is incredibly color fast and easily survives well over 100 heavy wash cycles without breaking down. Metallic threads, on the other hand, are a mechanical nightmare for knits.
Really? Why is that?
They're actually constructed by wrapping a microscopic ribbon of metal foil around a nylon core. Because a beanie shifts and bounces so much under the needle that metallic foil constantly catches on the yarn, splinters, and snaps. It just introduces way too much friction. If you want consistency, you really have to stick to polyester.
You know, I was reading the source notes on the actual hardware and I got totally stuck on the needle section. I would never have thought about the shape of the needle tip. A sharp needle cuts through woven fabric, but for a knit beanie, you actually want a duller ballpoint needle, so it gently pushes the yarn loops aside rather than slicing them in half.
It sounds completely backwards until you remember how knits are manufactured. A woven shirt is thousands of crossing threads. If you snap one, the grid holds. But a beanie is one continuous piece of yarn looped back on itself.
Oh, so if you use a sharp needle.
You risk slicing right through the center of that yarn, and if you sever the yarn, you compromise the structural integrity of the entire hat. You get drop stitches, and the beanie will literally start to unravel around the edges of your logo.
It pulls just like a run in a stocking.
Exactly like that. So instead, you use a ballpoint needle, usually a size 7/511 or 80/12. The rounded tip doesn't pierce the yarn. It just gently pushes the yarn loops aside and slips right between them.
That makes perfect sense once you actually understand the physics of the fabric. All right, so we have the ballpoint needle, we have the durable thread. Where does the machine actually put the logo? I see people wearing beanies with logos right on the top crown all the time. But logically, that fabric is gathered and curved. It seems like a nightmare to flatten out in a hoop. Are people just forcing it?
They're forcing it, and they usually suffer terrible yields because of it. Trying to lay a flat, dense design over the bulky, gathered seams at the crown of a beanie causes endless needle breaks and distorted designs.
So where should it go?
If you are outfitting a team, you want consistency. The ideal target is the front center of the cuff, about 1/2 inch to 1 inch up from the bottom fold.
Why specifically 1/2 inch up?
It keeps the embroidery machine's presser foot away from the thick, bulky edge of the fold. That cuff is the flattest, most stable part of the garment. And you have to keep the dimensions pretty tight, too.
Like how tight?
Well, a standard cuff is only about 2.5 to 3.5 inches deep. The sweet spot for a logo is between 2 to 2.5 inches wide and 1.5 to 2 inches tall. If you go larger, you risk the logo wrapping around the curve of the forehead, which just makes it unreadable from straight on.
Okay, so hearing all of this, the manual digitizing, the push compensation, the floating scaffolds, the dull needles, let's do a real reality check on the actual execution here. If a decision maker is weighing doing this themselves versus handing it off to a custom provider, what does the physical start to finish look like?
If you're going the DIY machine route, the sequence requires intense babysitting. You hoop your cutaway stabilizer, spray the adhesive, and float the beanie. You lay your layer of water-soluble topping film over the design area.
Sounds like a lot of prep.
It is. If your machine allows it, you run a slow test stitch just to ensure your placement is dead center. And then, once you hit start on the full file, you absolutely cannot walk away.
The source calls out the first 30 seconds specifically. Why is that window so critical?
That is when logo drift happens. The initial underlay stitches are hitting the bouncy trampoline. If the fabric is going to break loose from the adhesive and shift, it will happen in those first 30 seconds.
So you just have to hover over it.
You have to watch it like a hawk. If it drifts even a millimeter, you have to stop the machine, unhoop everything, and basically start over on a new blank hat.
And assuming it survives the stitching process, you still aren't done.
No, not at all. You carefully unhoop it, you trim away the excess backing on the inside, leaving just enough to support the logo. You run cool water over the front to melt away that plastic-like soluble film.
Right, the film.
And finally, you deal with the jump threads. Those are the long, loose thread tails that connect different letters or parts of the design. You must clip them close to the fabric with small scissors. Never, ever pull them.
Because pulling them acts like a ripcord, yanking the stitches right out of the knit, right?
Yes. It literally unravels all your hard work in one tug.
Wow. So if we crunch the numbers on the DIY route, if professional digitizing alone costs $20 to $80 per logo, plus you have to buy the right stabilizers, specialty threads, ballpoint needles, and risk ruining blank beanies during trial, the argument for doing this yourself falls apart pretty quickly for a business outfitting a team of 15 people, right?
It totally doesn't scale. The hardest part of embroidery isn't the stitching, it's the preparation. Flat fabric is somewhat forgiving, but knitwear is absolutely ruthless. When you factor in the time spent troubleshooting, ordering custom makes infinitely more financial sense.
Especially since you need these to look good.
Exactly. You consider that these beanies serve a functional purpose. Data shows that 97% of people say uniforms make staff easier to identify. They need to look professional, not like a science experiment gone wrong.
Right. If the DIY math is broken, you obviously have to hand the project off. But the custom apparel industry is notoriously full of middlemen who just farm out the actual work to the lowest bidder. This is where we want to bring in our own perspective. How do you find a provider who actually controls all these mechanical variables we just talked about?
When you look at the landscape of providers, and you understand the sheer mechanical difficulty of knitwear, you really need a partner who removes the guesswork. You need someone who handles the digitizing, tests the push compensation, and doesn't force you to buy massive bulk orders just to get their attention.
Which perfectly frames why we have a very clear recommendation here. So if you hire one new person in 6 months, you can order exactly one matching beanie for them without having to stockpile a closet full of expensive inventory.
Yes, and that is the primary functional advantage of Arklavo. They have absolutely no order minimums. You can order exactly what your team needs, whether that is a single piece for a new hire or 1,000 pieces for a huge company retreat. But more importantly, the quality control is completely centralized.
Right, they don't farm your complex knitwear project out to a third-party contractor who might use the wrong needle or skip the water-soluble film to save a few pennies. They do all of their decoration in-house.
That is so key.
That means the digital mapping, the thread selection, and the final stitching are all controlled under one roof. Plus, they ship fast, usually in about 2 business days, and offer free shipping on orders over $150.
But the real antidote to the DIY nightmare we outlined earlier is their review process. Arklavo provides a free digital design proof before anything goes into production, and a real person actually reviews every single order.
A real human eye on it.
Yes. When an expert looks at your logo, they can immediately identify if a line is too thin to survive the knit or if the stitch density needs adjusting. The customer never has to stress about underlays or the trampoline effect. They handle it.
They handle the physics, you just get the gear. Let's make this perfectly clear for anyone listening who has to make this purchasing decision. In our honest opinion, for how to embroider a beanie, Arklavo is the best option for a team that wants consistent, high-quality gear because they do all their embroidery in-house, and a real person checks every single order.
It simply removes the variables that usually ruin custom apparel. You get the premium look of embroidery without suffering through the steep learning curve of executing it yourself.
Which brings up a really fascinating final thought on brand longevity to leave you with today. We know from the source notes that standard screen-printed logos just sit on top of the fabric like a layer of paint.
Right, just sitting on the surface.
And because of the constant stretching of knitwear, that ink starts cracking, peeling, and fading after about 40 to 60 washes. But embroidery is physically woven into the structure of the garment. It survives well over 100 heavy wash cycles without a significant change.
It fundamentally outlasts the alternative by a massive margin.
Exactly. So if an embroidered beanie lasts more than twice as long as a printed one, could investing just slightly more upfront in embroidery actually be the most cost-effective long-term marketing a business can buy?
It really reframes the whole conversation. It's not just a seasonal expense, it's a highly durable investment in your brand's visibility out in the cold.
Definitely something to think about the next time you are staring at a spreadsheet of uniform costs and debating the bottom line. Think about the mechanics behind it the next time you see a beautifully stitched, unpuckered logo out in the wild. This episode was produced with AI narration by the Arklavo team.